Assalamu alaikum. My name is Najib Iqbal. My team member is Hamza Kazi, and we are working on the disease probability prediction system. The first thing that we need to understand is why do we need a disease probability prediction system? Most of the deaths, in human deaths are related to heart disease, stroke, lung diseases, diabetes, and tuberculosis. In 2019 alone, there were around 18.6 million heart-related deaths. And from 2016 to 2017, the direct and indirect costs associated with cardiovascular diseases were around $363 billion. Now, what would our system do? Our system would help in early detection of diseases, and that would lead to early prevention. How would early prevention help? Early prevention would help in saving lives. It would help in saving costs, not just the cost of individuals, but help in saving costs of insurance companies, and governments. Now, the data that we used was from Kaggle. There were two data sets that we made use of. One was heart disease data set. The other one was a diabetes data set. For data preprocessing, we did a few things. The first, in the age category column, the age wasn't discrete numbers. It was given in range. So we made use of the mid value for all the age values. Okay, for the columns that continuous variables in it, we scaled those columns by dividing it with the maximum value. For the columns that had binary values, for example, heart disease, उसमें yes or no था, smoking में yes no था, alcohol drinking में yes no था, तो उसको हम लोग labeling coder से yes was yes को हमने 1 कर दिया और no को हमने 0 कर दिया. Okay, and all the other columns that had multiple variables in it, we made use of one-hot encoding. For feature selection, we made use of the gradient boosting feature importance method and the random forest feature importance method. We dropped the few of the non-important features, okay, which didn't impact the target variable that much. We made use of a few models for our prediction: logistic regression, decision trees, random forest, gradient boosting, and all of the other models that you can see on the screen. इन सब पे हम लोगों ने ग्रिड सर्च किया, ठीक है. KNN को हम लोगों ने मैन्युअली इसके पैरामीटर्स चेंज करके हम लोगों ने वैल्यूज निकाली. ROC एक्यूरेसी ROC एरिया अंडर द कर्व निकाला. KNN की नंबर ऑफ n की वैल्यू बढ़ाने से वैल्यू बढ़ रही थी, इम्प्रूव हो रही थी, लेकिन इट वाज टेकिंग अ लॉट ऑफ टाइम and it was not as close to what we got through gradient boosting. Okay, now my friend Hamza Kazi is going to continue for diabetes.
Similarly, we ran different models for diabetes dataset as well. These models included logistic regression, decision tree, random forest, KNN, gradient boosting, stacking, and neural network. We also tuned the hyperparameters by using the trial and run method with the aim to improve the ROC AUC score. And we also used grid search to improve our model performance. After running the models multiple times, we found out that gradient boosting was the best model that worked for both the dataset, as it provided us with the best ROC AUC score for heart as well as for diabetes. So this is a small demo of our application. We have just employed the heart disease dataset for now. The user can use this application by entering different parameters and answering some basic questions and find out the chances of his catching the heart disease in the future. The same app can be employed for other data sets as well. Now we can see that the user has found that he has a chance of 23% of catching heart disease in the future. So this is how this app works. There are different potential beneficiaries of this project. These include the individuals, governments, health insurance companies, and hospitals. Individuals can use this app for checking the chances of catching a particular disease. Governments can make healthcare policies based on the predictions made through this app. Health insurance companies can handle specific cases of health insurance for their clients, and hospitals can plan for resources based on risk factors of a particular disease in a population. So we also faced various challenges during our project. These included the limited data availability of different diseases. For example, the data set for hepatitis and tuberculosis was very limited. Also, as we were working on more than one data set, so integrating multiple data set on a single application was a big challenge. Also, data availability was based on a specific region, the USA. So this might have also added bias in our data, affecting the accuracy of our model. So the way forward is that we can collaborate with healthcare organizations for data collection and diversify our data based on different diseases and location to make our model more accurate and effective for predicting all types of diseases. So that's all from our side. Thank you.